we are backend developers at OpenPath, and today we're going to see implementing a distributed object pool using Redis. What we did, we developed a distributed object pool capable of reserving and releasing objects in a distributed environment, and by that we mean across several Smalltalk images, and also keep the object collection synchronized across different instances of the pool located in different Smalltalk images. From now on, we can thought that we may have one Smalltalk image per machine or several. That it doesn't matter. So, what we need to solve, that we needed to implement this pool. At OpenPath, we did an integration with Prisma, that is a payment processor, and Prisma assigns a logical channel that is called a terminal. That quantity of terminal is fixed, and the terminal must be locked until the transaction is sent. Until the end, either the transaction succeeds or fails, because not only there are sequential numbers that must be updated correctly, but also at the end of the day, the batch closure, that is a summary of the transaction say by the terminal, must be correct. So, what are the challenges in distributed object locking? We have to ensure exclusive access to the object, maintaining consistent state across the images, and handling failures. For example, at process level or at image level. So, what are the synchronization requirements of the pool? We have atomic object acquisition. If two processes try to lock an object, only one of them must succeed. Also, we have to management timeout and list, because the object cannot be indefinitely locked. Also, we have to have mechanism for automatic log release for handling image failures. And also, all of this with a minimal performance overhead. Okay, here we have a model, and the important thing is the protocol of the distributed pool, that we have borrow, that in the pool returns any object, any free object, borrow an object, return an object, and two methods for adding and removing objects from the pool. Okay, this is in the title. How we solve it? Okay, we use Redis. What is Redis? It's an in-memory database, a key value database. Can be used as a database, cache, and message broker. It has a variety of data structures. As I say, it also provides atomic operations, transactions, and publish, subscribe, messaging support, persistence, and replication. We consider using Memcache for this, but we decided on Redis because Redis has publish, subscribe, messaging support. We need those two things: atomic operations and publish, subscribe, messaging support. This is a very high level diagram of the implementation. We have the distributed pool with the collections that must be synchronized, idle objects and borrowed objects. We have two connections to Redis, one for locking the objects, that is the messaging connection, and another one for that is the synchronization connection for the events, receiving the events. And also we have a show for dangling objects that that frees the object that still are being locked at the threshold.
Well, hello. I'm Santiago. I'm backend developer, like Diego. We both work at OpenPass. And there's another slide here. No. So I will show you this working. Well, the idea is to have a pool object in different images running at the same time. And the pool has a collection of objects that are available to borrow. And we have two times here. We have a timeout. That's the time. Well, first of all, this pool can can lend objects randomly, or you can ask for one in particular. Maybe sometimes in our case, we need to use the same terminal. For example, if we need to transmit reverse of a transaction, we need to use the same terminal that we used for the original transaction. So we can borrow an object, or we can borrow an object specifically. And this time locks you. For example, if the terminal 1 is borrowed, now if you want to borrow the same terminal, you can wait until this time, until the object was released first. And we have another expiration threshold time that represents the time when the object released automatically. For example, if it is locked and this time expired, there's a mechanism that free the terminal. So in these cases, we have the same pool in both images, and these are the 4 terminals that we have, and these are the idle objects. At this time, we have the same 4 objects, and we have another collection that's the borrowed object that is empty. And we can, for example, borrow one terminal, anyone. So you execute this in this image, and now we have the borrowed terminal is the terminal 2 for this image. And for this image, and if I inspect the pool borrowed objects at the other image, I have the same terminal that was borrowed, and this happened through the Redis. Here we can see this is the locked mark that we use. We use Redis to keep locked the object, and sorry, I will subscribe to the message, and to synchronize the internal collections of the pool. So these collections, the idle objects, and the borrowed objects, are the same in both images. No, borrowed and idle have 3. And this happened through the Redis usage. For example, now I will borrow another from this image. I ask for another terminal. Okay, now we have the terminal 3 for this, and we have Redis. Sorry, yeah. Two locks, one per object. And in the message, this channel is the borrowed object channel, indicates to the other nodes that which object was borrowed. And with that event, the pool synchronized the internal collections. When we return, for example, we return, I don't remember which, the borrowed object. I can return it. Okay. If I return this, so I returned the terminal. I can't remember which terminal we have. But now I have one lock, and in the messages we can see in the channel of returned objects a message that indicates that object was returned. And in the other image, for example, if we inspect the borrowed object, now we have this one, and we can return it just from any of the images. I can return it from this or from this. It's the same. This is the terminal 3, so I can return terminal 3 from here. And in Redis now I haven't got any lock mark, and both collections are synchronized. I have now the 4 terminals idle in the idle collection in both images. Well, this is one of our cases. For example, here when I talk about this time, for example, I imagine that I need to use the same terminal from different images. So the one in this image, the yellow one, will borrow the terminal 1. So it has the terminal 1 is borrowed. This is the lock in Redis, and in the second one, I want to get the same. Well, it is waiting. This 10 seconds here. If the terminal is not returned in this time, it will return nil. But if I return in the middle, I will try to do it quickly. Okay. I begin to try to get the terminal here, and I return it here. So now I have the terminal 1 now is borrowed at the other image. Well, I returned it, and we have another time that is a threshold, but we use it in certain cases. Not always we need to the objects be returned automatically, because here we have some transactions that depends one after the other. So we need to guarantee that the first transaction is ended for good or bad. But if it failed, it will need to be reversed and transmit to the payment. The payment processor. We need to transmit the reverse, so we can't release the terminal until that moment. So, but in other cases, yes, we after time, if the terminal is not returned, maybe because the one node yes, for example, if one node goes down, the other node take the task to release the terminal that was marked as locked in Redis. For example, here we have 30 seconds, and this is one example that I can borrow a terminal 3, for example. Okay, now I have it borrowed, and if I see the Redis here, okay, this is the lock, and well, after a few seconds, I hope this will disappear. And in that moment, the same, all the collections between the images will be synchronized. How much time? Oh, yes, there. Now, and here we saw the message. Okay. Oh, yes, the message in the returned object channel. And what else? For example, no, well, I don't know. Not, that's all. Maybe that's all the cases that we use. We decided to use Redis because of these two features. We can use it as memcache, for example, with a key and a value to mark the locked object, and we use these channels to publish and to subscribe to these channels to know when something happened in the other Smalltalks. Because while you subscribe through a callback, and you analyze each one of these notifications, and it depends on the channel that were published, you add or remove the object from different collections. Well, nothing else. I don't know if someone has any question. Yes.
I didn't get the mechanism where if two borrow an object at the same time, so you have to get an object and move it into another collection or something. So that's a borrowed object. So what is the insurance that two borrowing actions at the same time do not return something corrupted, or return the object to two images?
Because the first one that can write the key in Redis, it wins, and the other one it receives another response from Redis that indicates that the object is just been locked before.
So that means that the two operations together are atomic. Because
set nx is atomic in Redis. So whenever the two processes try to set the variable, that in this case it will be the object ID, the second one fails. That's the atomicity. The command setNX in Redis is atomic, and it only answer, I don't know, 1 or 0. If it does not exist before.
Creating the lock is an exclusive operation, and then we find on the service container.
Yes, yeah. Okay.
Have you guys thought about or implemented anything related to like multiple readers, like you're sharing read-only, for example, is one thing, because what you just explained is like the first one that writes wins, and the rest is optimistic. It's like an optimistic write. But have you guys found some for the use case? I don't know what's the use case that drive that remote object framework. Made anything that is related to shared reads and you have policies, or how are you working with that?
Okay, let me get it. So, no, I think it's a more classical problem. So, only one process at a time can use some object.
But also for read and writes both.
Oh,
so if you have like 2,000 clients wanting to read the same object, it's only
there's only one.
Okay.
I noticed you are using VA. Did you consider at some time using SST? Yeah, it has something about distributed objects and replication. On VA Smalltalk, you have the server Smalltalk framework, and I think I remember it has something about distributed objects. Did you consider it, or were you not aware of it?
No.
It's kind of difficult to use, but it may also help, just in case.
No, we didn't. We didn't consider. But not regarding that question, but something that I want to show also is, I forgot, but now I remember it. We are in time to show it. For example, we developed an API to monitor the state of the terminal. So you can see maybe in Grafana if there are terminals that are locked for more than more than this threshold time. For example, I will borrow these two objects, no? And I will. Oh, I forgot to open Postman. Wait a minute. Oh, sorry. No. So I have, for example, here I know the pool demo has 4 terminals. 2 are idle, 2 are borrowed, and I have 2 that overdue time because it exceeded the threshold, the time that we set before. Indicate that there's something you need to pay attention. Maybe it can be problems, communication problems with the payment processor, or something about the network in general. Well, we use this, and this API consumes or use the same collections that we were looking here. For example, after time, if I return one of these or return all, for example, 1. Oh no, but I have terminal 2 and 3, so terminal 2. Okay, now I still have the terminal 3 locked. No, now are all available. It's in the indicator. Maybe our client need to put more terminals in the pool we see that it always exhausted the pool, it's an indicator that you need to add more terminals to it.
I had another question was, can you grow the pool? Are you limited to 4 terminals, for example? Or can you have a minimum of 4 and then add more and then come back down if there wasn't?
No, you can add more terminals, each one. Yes, it not depends on, the limit is not, okay, it's not, in Smalltalk, it's because a contract between the client and the payment processor. They need to contract more terminals if they need to use more.
To wrap up, no, we didn't consider this that option because we were not aware. But because we use memcache, something like memcache, and also we needed the. So we finally ended up Redis.
You did use your time. You're using this only to pull terminals, or are you pulling anything else? Just to understand the use case of this.
No,
The
we can
Redis
pull
pool.
anything else, but in this implementation we are tied to our model because, for example, we look objects by an object ID that we use, but it can be arranged. Maybe you can explicitly determine which method do you want to identify the objects, but it's for any object.
Okay. Okay. Applause.
Yes, the idea.